Aloha. My name is Brie, and I work at Airbnb. Big changes at big organizations is hard. There's a lot of people to convince and a lot of code to migrate. I'd like to share with you how we brought TypeScript to Airbnb. I appreciate you all being here with me. I know you could be out at the beach with your snazzy new towel, but I hope there's something in here for everyone. Whether you're navigating a big change at your company, and this could be used as a sort of case study, whether you're actively migrating to TypeScript now, and there are tools and techniques that we'll talk about that can help, or if you've heard about TypeScript and want to learn more. First, we'll cover what TypeScript is, what we mean by at scale, the process of proposing TypeScript at this scale, addressing questions and concerns along the way in response to the proposal, how we gradually adopted TypeScript, and migration strategies that we're using to move from JavaScript to TypeScript. By a quick show of hands, how many people have used TypeScript before? Oh, cool, that's a big number of you. Not everybody raised their hands, so let's give a quick introduction so that everybody's on the same page. Suppose we had this greeter function. It takes a name and returns hello, that name. So if we passed in JSConf, it would say, hello, JSConf. How friendly. Here's what that code would look like in TypeScript. Notice that it's quite similar. The only difference is that we've annotated the parameter with what type it is. So if we use this function in our TypeScript project, and we pass a string, everything compiles fine. But if we pass something that's not a string, in this case an array of strings, TypeScript will give us an error that a string array is not assignable to a parameter of type string. We didn't have to refresh the page, click through our flow, look at the error in our console, and trace back through where the error happened. We got this error immediately in our editor right after we typed it. We can express the type of other objects as well. This interface describes the shape of a person object that has a first name and a last name. And you can describe types for more complicated constructs. TypeScript not only comes with a compiler that can tell you when something has gone wrong, it also has a language server that editors can hook into for things like autocompletion, find usages, refactoring, and more. In this example, we've hooked up the type for our with styles React hierarchy order component, so we get autocomplete for the hundreds of CSS properties it accepts, including inline documentation. Amazing. I didn't have to flip back and forth to the docs pages. I got all of this in my editor. With types throughout our code, we can do more as it's being authored. This just scratches the surface of what TypeScript is capable of, but gives you a sense of the kind of errors it can help catch and the tooling it enables. So that's the TypeScript part. What about the at-scale part? Oh, is there a problem? Oh, thanks, TypeScript. I'm not actually making all this up. If you did typo a variable, it would give you an error that looked like that. So it actually is a real thing. So let's fix that. So the scale changes the conversation. I've been on small teams before where it was just, hey, do you want to use TypeScript? Yeah, sounds cool. Let's use it. But as you scale up to hundreds of engineers and more code, that conversation changes. The change that we were proposing is using TypeScript in our main repo, the one that powers Airbnb.com, and making it a primary language for front-end development. More people are affected by the change, and more code would have to be migrated. Let's quantify what we mean by at scale. At Airbnb, we have lots of JavaScript. There's over 2 million lines of JavaScript checked into our main repo, and over 100 internal NPM packages. These are separate repos that we've packaged up to an internal NPM registry that we can share across repos. And that's a lot of code. We still got some backbone in there. Talk about Sean's history of JavaScript. We got some history over the Airbnb's decade. So we also have lots of engineers interacting with this code. There are over 1,300 at the company, 200 of which are front-end. The majority of these front-end engineers contribute to that main monorepo. Those numbers paint a picture of the environment in which we were proposing TypeScript. And what did it look like at that scale? Every month, we have a fun meeting where all the front-end engineers around the company get together, and we geek out about new front-end technologies and patterns. For things we want to consider in more depth, we draft proposals that outline things like benefits, trade-offs, alternatives considered, exit strategy, and long-term owners. People weigh in on the pros and cons of these proposals, and we decide as a group whether it makes sense to move forward. This ensures we make deliberate decisions about what we commit to as a broader team and avoid hopping on the hype train without legitimate technical justification. We'd been exploring TypeScript at Airbnb since 2016 on smaller teams, and a static type system was a top request from a 2017 front-end survey. Given this positive signal, Joe and I, shout out to Joe, second row there, we drafted a proposal for TypeScript and presented it to the front-end working group. The proposal detailed why TypeScript made sense at Airbnb. Let's highlight some of the main reasons. Airbnb's mission is to make it so anyone can belong anywhere. Every issue a user encounters with our product gets in the way of that mission. The same is true of the products you all are working on. TypeScript helps prevent bugs, which in turn helps our end users. TypeScript also enables a wealth of developer productivity benefits and tooling, like editor auto-completion and refactoring like we saw earlier. With TypeScript, engineers can move faster, more safely. We are investing in GraphQL and Apollo at Airbnb, which lets us generate TypeScript types from our GraphQL schemas. This means that we can get end-to-end type safety because the types used by the backend and the front end share a single source of truth. A backend engineer can make a change to the API without unknowingly breaking clients, and front-end engineers can be confident about what data will be coming back from the server. Type mismatches have been a major source of bugs for us, so this end-to-end type safety was a major selling point. Sounds great, right? But there were lots of questions and concerns in response to our initial proposal. Let's look at a few of them in more depth. Our monorepo depends on our internal NPM packages. Do we need to convert those to TypeScript first in order to get autocomplete and type checking? So this is the predicament we have. We have our TypeScript project that depends on a JS NPM package. How do we get types for that package? It would seem like the package needs to be converted to TypeScript first. But that's problematic because we'd be blocked on the maintainer converting it, and maybe they're reluctant to do so because at the early phases of our proposal, it wasn't sure we were going to move forward with it. But on the flip side, in order for developers to have a good experience with TypeScript, we needed that type safety. So how do we get around this seeming chicken and egg problem? TypeScript has a feature called declaration files, files with a d.ts extension, which we can define types for JavaScript files. Let's look at an example. So we have the greeter function that we saw earlier and the corresponding d.ts file on the top. There are no implementation details here. It only describes what the types are. TypeScript stitches these together such that the declaration file is used at compile time and the original JavaScript is used at runtime. So let's go back to our original scenario and see how declaration files can help. Sure, if that project had been converted to TypeScript, we could generate a d.ts file as part of the TypeScript build, but we were considering that that wasn't an option. So instead, we could put the declaration file in our TypeScript project. Another choice is that we can create a separate NPM package and put the declaration files there. This is nice because now we can share the declaration files across several repos. And this is how types for things like React work. You install React, and you can install a types React package. The types for React, along with those for 5,000 other packages, live indefinitely typed, a community-maintained repository. The vast majority of public dependencies we had in our main repo were already typed and definitely typed. The active community around TypeScript was a major selling point. And we've contributed back. I'm sure there are people around this room that have contributed back. Thank you. Definitely typed works great for public NPM packages, but what about the internal ones? We mirrored this definitely typed setup internally by creating a separate NPM scope. So instead of installing from types, you'd install from Airbnb types. And the repo is set up similar to how definitely typed is. So we could add our types there and publish these types internally. And we've open sourced a starter kit if you are interested in setting up this sort of thing. It doesn't have any types in it. It's more just the setup for how you can add, test, and publish your own types. How many bugs can TypeScript help prevent? A recent study, To Type or Not to Type, showed that 15% of bugs in a selection of GitHub repos were preventable with TypeScript. Internally, we have a process for documenting incidents that occur in production. This is a blameless process. The point is so that we can learn from our mistakes so we don't repeat them in the future. So I literally sat down and read through 6 months worth of postmortems. Super fun reading, right? Some of my favorites, like Tale of the Uncut Type Error, The Peril of the Permuted Parameters. OK, maybe they didn't have such exciting names. In any case, I categorized them as JavaScript related or not, and determined which of those could have been prevented with TypeScript. Let's look at an example where TypeScript would have helped. We made a change to our shared input component that broke a form on a settings page. Users were unable to submit the form because it no longer passed validation. Here is a simplified version of that shared input component before the change. It takes an onBlur prop and passes it straight through to the input element. A change was made to add a new onBlur handler. But there was a subtle bug. Can you spot it? The event parameter was no longer being passed to the onBlur prop. This caused an issue several hops away in a different repo. The input component was being consumed as part of a Redux form, which expects an event or value to be passed in order for the validation to work properly. Without the event, the form no longer passed validation, which meant the submit button was always disabled. How could TypeScript have helped us here? The types for Redux form capture the constraint we saw in the docs. The onBlur prop must be passed an event or a value. So if we had been using TypeScript with Redux form types hooked up, we would have seen an error at the call site where the event wasn't being passed. Another common class of issues involved strict null checks, where you use a property to structure or try to invoke something that could be null or undefined. You've probably seen that one before. Another was type mismatches. TypeScript tells us when we try to use types that are not assignable to one another. So now that we have a better sense of the common kinds of postmortem bugs TypeScript can help prevent, what's the overall percentage? 38%. We found that 38% of incident-causing bugs that reach production, bugs that have real effects on our users and bottom line, could have been prevented with TypeScript. This was a huge finding for us. It helped make the impact real. We saw light bulbs go off as we replicated some of the incidents and showed people the error TypeScript would have given. Sure, we could have written tests to catch these sort of things, but static type checking adds an extra layer of protection. So if you have access to a similar history at your company, it could be worth taking a look with someone who knows TypeScript to see what this percentage looks like for you. Do teams want to switch to TypeScript? We piloted TypeScript on several teams, specifically targeting teams that hadn't used TypeScript before to gain additional perspective. We helped them get set up and gathered feedback along the way. After using it for a while, we sent a survey to them asking whether we should continue investing in TypeScript. And the feedback was overwhelmingly positive. We'd recommend using this sort of trial period for testing out a new technology or pattern. The front-end working group was on board with it because it was self-contained and it was easy to roll back should we not move forward with it. And it helped the proposal because we could gauge whether teams actually liked using TypeScript. There were concerns around build times. We measured it and found no significant impact. We have over 500 ESLint rules enabled in our main repo. With the TypeScript ESLint parser, we were happy to discover that most of them just worked. If we were to ever move away from TypeScript in the future, we could strip off the types and end up with roughly the same JavaScript we would have written otherwise. So one by one, we documented, considered, followed up, and came up with solutions to the questions and concerns raised. It was important to us to work with detractors and hear out their concerns. We converted many of them to advocates in the end, and our proposal became stronger from their feedback. After sufficiently addressing concerns, we surveyed all front-end engineers on whether we should adopt TypeScript. Given the positive response, we had enough evidence to move forward, and the proposal was approved. Woo! From there, we gradually expanded adoption. And at this point, we had completed the pilot phase. That was valuable for proving out TypeScript and getting the foundation in place. We ironed out frictions early and improved tooling and documentation so later teams would have a smoother on-ramp. We have ongoing contact with the TypeScript team and help surface issues like prioritizing better handling of default props as one example. This phase also grew our internal TypeScript community. Most people at Airbnb don't know TypeScript yet, so this meant more people could help and answer questions. Next, we moved into a beta status, and teams could opt into using it. To help onboard teams, we created internal documentation and a style guide and hosted learning sessions. We set up a Slack channel, an internal Stack Overflow tag, a Google email group, a GitHub group people could use on their PRs. We wanted to make sure people could get the help they needed. The final step is graduating TypeScript to general availability, meaning it's stable and everyone should start using it. We're actively approaching this at the moment, and The remaining steps are solidifying the style guide, documentation, ramping up internal education efforts, and migrating more code. We're about 50% of teams using TypeScript, and 10% of the files in our mono repo have been converted so far. Using this gradual approach made for smoother adoption. If we said from day one that everybody should start using TypeScript, person after person would have run into the same issues or had the same questions. Instead, we could figure things out on a smaller scale and carry forward, and those answers would carry forward as we expanded out. We've been exploring a couple options for migrating our code to TypeScript. Our original migration strategy was a JavaScript TypeScript hybrid. Let's see how this strategy works in the context of our monorepo. This is a simplified version that I came up with by literally going to Airbnb.com and giving reasonable names to the things I saw. So no company secrets here. Let's zoom in on the Homes project and see what it would look like to convert it using the hybrid strategy. We added a TypeScript config file and renamed individual files from JS to TS or JSX to TSX. TypeScript errors pop up, and we proceed to fix them. An awesome feature of TypeScript is that not all code has to be converted before it can compile and run. The Allow.js configuration option allows JavaScript and TypeScript files to live side by side. So at this point, we can check in what we have so far, and the site still works. We don't have to pause development, migrate the whole project, and then do that first. We can migrate instead file by file. We repeat this process over time until the whole project is migrated. On the topic of migration, I wanted to take a brief moment and share some tips we found helpful. The first is tsfixme. We added a global type alias for TypeScript's anyType, which means something could be anything. We called it tsfixme to indicate that it should be revisited and fixed up later on. Best practice is to avoid any because it loses type safety, but it can be helpful during the migration process. The tsignore comment silences the error on the following line. Properly typing a file might involve unraveling some deep chain of dependent types. We try to avoid this by converting leaf files first, but sometimes it's inevitable. So tsfixme and tsignore can help split things up such that incremental work can be checked in. These are intended to be temporary, and we're planning on adding type coverage tooling to help remove them as we refine the types over time. In JSX, we use prop types on our React components for runtime type checking. When converting a JSX component to TSX, we can either remove the prop types in favor of a TypeScript type, or keep the prop types and add a TypeScript type in addition. In our shared React component library, for example, we wanted to keep prop types so that JavaScript consumers could still get runtime checks, but to avoid declaring a second type that would need to be kept in sync with those prop types, we created a props type utility that is able to derive the TypeScript type given the prop types and the default props. In this case, the prop types and default props get combined into this final type. And if you're curious how this works under the hood, I created a gist that you can check out. Recently, we've been experimenting with a revised all-in TypeScript migration strategy. So let's go back to that Homes project we were looking at before and use the all-in strategy instead to see how it works. We start off with all.js. We convert everything over to TS, get the project compiling. Perhaps we use some looser types than we'd like, but we still have TypeScript's strictest options turned on. And then we proceed to refine the types over time, removing the tsfixmes and tsignores. This has some advantages over the hybrid strategy. It's easier to refine type by type rather than file by file. If you're developing a feature and you only care about adding one type, it's a much lower barrier to entry to just fix up that type in isolation rather than having to convert the whole file first, fix up all the errors, and then add the type you care about. Not having to rename the file also means that it's easier to review. Sometimes if a file is renamed in one commit, then changes are made in another, they show up separately in code review, and the reviewer has to piece together what happened. It also makes it clear what types are missing. TypeScript's inference is powerful, and we can leverage it for large portions of a file. Some files require a few to no tsfixmes in order to compile. TypeScript can figure out the rest. Another is that developers can use a consistent mental model. They don't have to context switch depending on what file extension they're in. Like, why can't I add a type here? Why am I not getting compilations errors there? Types can be added, consumed, and type checked in all files. Yeah, that sounds great, but how do we migrate all the code? Code mods are a powerful tool for large-scale code modifications. In their simplest form, a code mod could be a global find and replace across a project. You might have done this in your editor before. And there are code mod libraries that do use regexes, but they are brittle because they might break depending on subtle code style variations. Alternatively, we can use an abstract syntax tree, which is something that the speakers earlier brought up too. So this is the AST representation of this code. Notice how for every piece of code on the left, it has a corresponding node in the tree on the right. So just for fun, say we wanted to write a code mod that reverses all the identifiers in our code. We'd start with our code as the input, create an AST out of it, modify that AST, and emit new source code out. The power here is that we are making this change programmatically. The alternative would be editing each file to make the change, and this works fine if you only have a handful. But once it gets to be more like 1,000 files, the thought of manually changing them gets really sad. Facebook's JS Code Shift is a popular tool we use for code mods at Airbnb. This transform captures the modifications we just made to that AST to reverse the identifiers. We find all nodes that correspond to identifiers, replace those nodes with new ones with the name reversed, and then return the new source code back out. Missy Elliott would be proud of us, because we flipped it and reversed it. I got last, that's great. I was debating, I was like, should I do it, should I do it? We took the code and we modded it, found the identifiers, flipped them and reversed them. Is your Wicca Wicca friend yet? Oh yeah. A tool that cannot help you with your rap skills, but can help you with your code mods is ASTExplorer.net, which Sean pointed out earlier. It has the source code, the transform, and the output, and an interactive AST all in one place. Also, I just landed a definitely type PR to add types for JS Code Shift that makes it easier to author code mods in TypeScript. Several patterns emerged while migrating JavaScript code to TypeScript. We repeatedly moved static class properties into the class body for React components, created a props type, annotated React lifecycle methods. We encoded these as code mods so that we could run them repeatedly over more code. And we packaged them up in a tool called tsmigrate. The goal is to send a JavaScript project in and get a compiling TypeScript project out. Now, you'd still need to refine the types over time, but it gives you a baseline to work from. We applied this tool to our internal shared React components library, which is used everywhere across the site. We had types for this in our internal definitely typed, but it was hard to keep those up to date with the rapid development of the shared React components library. So instead, we wanted to emit types directly from the source. So it was our first target for tsmigrate. We converted over 30,000 lines of code to TypeScript, and instead of devoting the whole team's time for weeks to do this, we could run our suite of code mods and do it in minutes. We used the type information from prop types and made use of tsfixme, and we are continuing to refine from this baseline. But even with this, we generated meaningful TypeScript declaration files we could consume in other repos. In case that PR line count looks a bit scary, with the TypeScript compiler, Hapo for visual regression testing, and our Jest test running in CI, I felt confident that my changes wouldn't break anything. And of course, we made sure the site was still working. No regressions, woo! We have since run tsmigrate in other places, and we're iterating on it, and we're planning on using it across more and more code. We plan to open source it so that you can use it to migrate your code too. Thank you for following along this journey with me. I'd like to leave you with some key takeaways that we can draw from this TypeScript transition that apply more generally. Affecting change at a large organization can be a challenge, but strong evidence and addressing questions and concerns make a compelling case. Adopting change gradually helps reduce friction and prove out the value. A clear migration path helps teams move over to new patterns, and tooling can help expedite the transition. I started this work while on a product team feeling dissatisfied with my tools. When I learned that there were others in the company who also wanted to make this change, I partnered with them and carried the initiative forward. It's all too easy to complain about things, accept the status quo. Positive change can come about through the actions of people who care. So I'd encourage you to pursue the things that you're passionate about, your organization, to make life better for you and those around you. Thank you all for listening, and thank you to everyone at Airbnb who contributed to this effort. Shout out to Joe and Mohsen who are in the audience, and Miles in Portland. And there are a bunch of other awesome Airbnb engineers who would love to talk to you. I also have some TypeScript stickers and some Balo keychains for the first 30 people that come find me. So just as an incentive. Yeah, thank you so much.